Hi, I'm Philip, and I will present you the most interesting changes in open source firmware validation since the previous OSFV status 2 quarters ago. We'll first do a short introduction to OSFV, then show some stats of the repository, talk about the recent improvements and the future plans. So open source firmware validation is the open source validation environment for validating our open source Dasharo firmware. It's based on robot framework, and for more details, I invite you to check the previous presentations by Maciej. As Maciej said in previous presentations, the releases of OSFV happened very rarely. The main branch was far behind develop branch, which was pretty confusing. So from starting from now, we will switch to a rolling release. So develop branch is the default branch, and the updates will be there much quicker. Since the last presentation, we had about 120 merged pull requests, so the repository is growing. Looking at graphs showing the increments between quarters, we can see that the previous quarter had 50 merged PRs, and this quarter had 74. So the pace of development is pretty steady. Now, at this moment, open source firmware validation has 990 total test cases. That's 415 more than since the last presentation, and I will explain shortly why the total count increased by that much. The most interesting test cases added were the fast boot test suite, which tests the feature Piotr talked about earlier. We've got a new test suite for testing ACPI drivers, USC test suite for testing the always-on USB feature, and since the last presentation, we've added multiple benchmark test suites. UPP and CPP are two test suites that test the performance of the CPU. We've got ETH-perf, which tests the performance of Ethernet network connections, and VIO, which tests the speed of the disks. We've also automated the CBO test suite, which tests the custom boot order. Most of the AUD, which stands for audio tests, were automated. And we've added a couple new test cases to the NVM test suite for testing NVMe on double PCIe. And additionally, the TPM suite was extended with a couple tests for TPM physical presence interface, which allows you to modify TPM from the operating system, but then the changes need to be authenticated by your physical presence after rebooting the device. And the tremendous increase in total count of test cases comes mostly from the extension of UTC test case, which tests USB Type-C, because we've decided that most of the tests, there are about 100 of them, should be repeated in various configurations. Every test should specify what docking station it is performed on and whether Intel ME is disabled or enabled. So about 250, 100 test cases are UTC variants. Since the last presentation, we only have one new platform supported, that is Protect VPP 2440. It's a slight improvement over the VP 2430 because it has to 10 gigabytes Ethernet ports, while the previous version has 2.5 gigabytes Ethernet ports. So here are some key changes, maybe more or less interesting than the test cases. So first, we've added support for Fedora, and most of the test cases in OSFV can be performed on this operating system. What's maybe more interesting is that we are now prepared to support countless operating systems. It won't end on Fedora. Right now, we test mostly on Ubuntu, and most of the cases can also be performed on Fedora. We've changed the test ID naming convention to support many operating systems. Previously, the red part, the second three numbers part of the dot was used pretty freely, but now it is reserved as an environment ID. So whenever you see a test ID and it ends with 201, you can know that this test has been performed on Ubuntu. And if it ends on 202, it's test on Fedora. Right now, by looking at the test modules, we have around 30% test cases implemented on Fedora. It's not the percent of tests that support testing on Fedora, but it's a total percent of test cases performed on this operating system. So because we are mostly testing on Ubuntu and Windows, the perfect percentage should be about 30 to 50%. That would mean that most of the test cases can also be performed on Fedora. A big change since the last presentation is that we are dropping the support for Dasharo test and feature matrix on Google Docs. We've had many problems with this spreadsheet. It was very slow, it was breaking down very often, and it wasn't reliable at all. When you were looking for releases for a platform, you had to scroll these tabs down here and choose something that interests you. Then on every column you had releases, and every row showed a result for a test case. Right now, the main place where you can find the results of open source validation of Dasharo is OSFV results repository on GitHub. In the README, you can find links to all of the directories for platform model families. So that's where you should start when looking for a release that interests you. So let's say we would like to check what's going on with Protectly VP66 family. That's right here. So when I click the link, I will get to the directory which contains all the results for all the releases for this model family. So let's say we are interested in VP6650 platform, and last week there was a release of a release candidate VO92 RC1. When we click on this file, the CSV will be rendered in GitHub. We can check how the results look. So if we would be interested in, for example, if Wi-Fi works well on this platform, we can just Control F and search for Wi-Fi. There's the test Wi-Fi scanning on Ubuntu and Windows. It wasn't performed on any other operating systems this time. We can see that the test passes, so scanning for Wi-Fi networks works fine on this platform. But this result here has a link attached. When you check it, we can see that there was a small issue with OSFV, but the feature works great because it was tested manually. A next big change is that we are now deprecating the unified test documentation that's Dasharo. Keeping it in sync with OSFV turned out to be impractical. that places often contradicted themselves, and dropping the support for this documentation will allow us to keep the tests even more reliable. So now when creating new manual tests, the test will be still implemented in Robot Framework, but the steps to execute the test will be written in a robot, and running the test will actually spawn those pop-ups with commands to execute, steps to perform, and whenever the result of the test would be decided, the program will ask the tester what was the output or result of doing something, and based on that, the result of the test will be decided. So the whole process of testing will be documented. Another improvement to reliability of OSFV will be adding hardware tests to our CI. It was suggested in the last presentation, and we are now starting to implement this. It's still work in progress, so there is no exciting results for now, but we've decided to choose those two platforms as a start: an MSI with an Intel processor and a PC Engines platform with an AMD. So other than testing on hardware turning out to be very important to keep the OSFV repository reliable, by using an automatic test scope determining scripts, we can also make the testing much quicker. It will work simply. If a test case had been modified, then the whole affected suite needs to be run on those two platforms. And when we add more of them on all of the supported platforms to catch all of the sometimes very complex edge cases in OSFV. Additionally, if a library has been modified, then all of the test suites that use the library will be tested. And if a platform config had been modified, then a small set of minimal regression tests will be performed on the affected platform, just to make sure that everything works fine on every pull request. Our current priorities for the future will be extending the CI tests on hardware to ensure that OSFV works as reliably as possible. Because when identifying the main causes of release cycle taking too long, we identified that testers generally spend a lot of time just fixing the tests that last time worked fine, but someone merged a pull request that they tested on just one platform, and on another platform that works a bit differently, the test doesn't quite work. So by doing this tests in CI on hardware, we hope to ensure that the release cycle will become faster. So that's our main priority for the next quarter. Last presentation, we said that we will also focus on full support for CBIOS, and that is still on the roadmap. That will be all, unless there are some questions. If there are no questions, then
there are
present some bonus content.
Do you hear me?
Yes, I do.
Yeah, so there are some questions. One question is, maybe I will read this. How much non-automated work is needed for each validation run? I guess it depends on the platform, but can you say percentage-wise, or maybe in rough numbers, like how many tests you have for one release cycle, and then how many of those are automated, how many are not, maybe per segment or per given platform?
Yes, it very much depends on the platform, and it very much depends on how reliable OSFV is at this time for this platform. because in theory, like 80% of test cases should be performed automatically, but because of the issues with reliability, which we are working hard to solve by adding the hardware test in CI, I'd say like 50% tests could be performed manually, but that's a rough guess. So maybe I could just do a quick flash of a couple of interesting bonus informations. So we are working right now on our own tool for documenting the testing process and the results. It's called OSFV dashboard, and it's work in progress. We are using it internally right now and performing beta tests of this tool. We believe that using it, the results will be able to be presented much more accurately. Here are some screenshots how this tool looks for someone that looks for releases. You can choose the platform, the release, and the specific DUT the tests were performed on. You can check the results, whether the test was automated or manual, so that will solve the previous questions when the tool is released. There is no planned date of releasing it, but the development is going on right now.